All right, we're going to start talking about graphing linear inequalities in two variables now. Okay, so we've been doing linear inequalities in one variable. That was just where we had the horizontal line, and we would take a point and we do this sort of thing, right? Okay, but now we're going to do it in two variables. Okay, as if it were a line, but now it's not a line; it's a linear inequality. So here's what we'd like to do. We'd like to graph the set of solutions to something like this: 3x minus 2y is greater than 2. Now, we've got two variables, so instead of having a one variable solution, that is a line, just a plain old line, we're going to need a set of axes for a two variable set of solutions. So a solution to this equation, a solution to this inequality, will be a pair of numbers, an x and a y. And the question is, what kind of numbers make this true? Well, let's think out loud for a moment here. Okay, if I put the number 1 comma 0 in, will that work? Well, it might. Let's see. Put in 1 for x and I get 3. And I put a 0 in for 2, for y, pardon me, I get 2 times 0 and I get 0. Is that greater than 2? Yes, it is. Okay, so the number 1 comma 0 is one solution to this, but there could be many others. Okay, so what pairs of numbers, probably what this should say, okay, what pairs of numbers make this true? Okay. Here are the steps we're going to look at. Okay, in order to graph our solutions, because our solution is going to be a graph, we're going to do three things. The first thing we're going to do is graph the boundary line. Okay, in order to do this, what we do is we change the inequality to an equality, and then we graph that line that we get when we make it an equality. The second thing we do, part number 2, is if the inequality is strictly less than or strictly greater than, then we make the boundary line dashed. If it's not strict, then we leave it solid. So this is where a pencil is going to come in super handy. You're going to draw your line with a pencil, and then when you're done drawing the line, you look at the original inequality. And if it's an inequality like this, without the line underneath, okay, you're going to erase little parts of the line to make it a dashed line. If it's non-strict, okay, that is to say that it could be equal to, it's not that strict, it could be equal to, then we leave it as a plain old solid line. And the third thing we do is we pick a point not on the line and plug it into the original inequality. If the statement is true, we shade the area containing the point. If the statement is false, we shade the other side of the line. Okay, the shaded area ends up being our solution set. Okay, so we're going to try graphing this equation, this inequality, pardon me. The first thing we do is we change the inequality to an equality, and we try to graph that line that results. Okay, let's see if we can do that. So this is in the standard form. So if I let x equal to 0, then I get negative 2y equals 2, and y equals negative 1. So setting x equals 0 gets me the y-intercept. Likewise, setting y equal to 0 means that 3x will equal 2, and I'll get the x-intercept. So this method is the method we use when we want to find the x-intercept and the y-intercept. Okay? So I'm going to graph those 2 points, my x-intercept and my y-intercept, and I'm going to run those to a line between those 2 points. Here's what I get. Okay? Pretty straightforward. Okay? Here's my x-intercept. Here's my y-intercept. Negative 1 and 2/3. Pardon me, my y-intercept and my x-intercept. Okay? Now, since the inequality is, quote, strict, we're going to make the line dashed. And I'm just going to go ahead and do that kind of by hand here. Pretty nice, right? Oh. And if I'm doing this with a pencil, I'm going to literally take my eraser. I'm just going to erase little sections of the line. Next thing we do is choose a point not on the line. Now, if you got an option, always choose the number 0, 0. It's an easy number to choose. So we plug that in into the original inequality, and we decide 3 times 0 minus 2 times 0. Is that bigger than or equal to 2? Nope, that's false. So the point right here on the graph, this point here, is not a solution to the equation, to the inequality. So this sector out here, this section, will not be shaded. Instead, we're going to shade this side. And when I say shade, you can just do this sort of thing. Okay? Here is my solution set. Okay? A dashed line, and the region is shaded over here. Again, when you have a pencil, I would just go ahead and kind of do this sort of thing, right? That's totally fine. As long as it's clear which side of the line is being shaded, it doesn't have to be perfect. Okay. So now, your turn. I want you to graph the solutions to this. Okay. I'm going to make you pause the video, ask you to do the problem, and then I'll give you the solution on the next page. Okay, so go ahead and pause it. Okay, so hopefully you have a nice graph now. What you were going to do is set this equal to an equal sign, graph it as if it were a plain old line. We're not going to dash it because we have an or equals to. That means the line is included. Any point on the line counts as a solution. And then once we do that, we're going to choose 0, 0 because I don't think that's on the line. Choose 0, 0 on the set of solutions. And decide, is 0 less than or equal to -4? 0 is greater than or equal to -4. So again, 0 is not going to be in our solution set. So here's what we're going to do. Here's the line we graphed. It's a solid line because the line is part of our solution set. We choose the line 0, 0. When we plugged it into the inequality, we found out that that made a false statement. So 0 is not a solution. That means stuff on this side of the line is not the solution. Stuff on this side is. Okay, and that's it. That's graphing linear inequalities in two variables. Nice work.